is Ged Finch from XFrame, based in New Zealand. I'm based in Sydney, the land of the Gadigal people. So Bujari Gamarua. I hope I said that correctly. We'll just wait a few minutes while people are coming in. So for those of you who may not have got my email earlier this morning with regards to the CPD question sheet, it is also in the handouts as well. So if you're looking for the CPD question sheet, it is also in the handouts. Just note, there's no need to send your question sheet in to me. If you've attended this live session, then you will be automatically sent the the CPD certificate. For those of you who will be watching the recording, I will need you to email me your completed answer sheet. And that way I get notified that you have actually watched the recording. So if you are watching the recording, which is no one on here now, please email me. My email address is on the test sheet. Now we will be taking questions. Now with the questions, because Ged is going to be delving into some technical stuff further on in the presentation. So what we'd like you to do is, if he's on a particular slide, please write your question in the chat box and also the slide number. If you forget, that's okay. But I know that what Ged is presenting is really cutting edge. It's a very different approach to what we do with fit outs. So I know that there will be questions. So I am going to start off with a bit of a promo. So just a little bit about who we are as a company. So what Abodo does, I'm based in Sydney. We're our Vulcan timber, which is our key species here in Australia, and it's stocked in all the main capital cities here in Australia. So really, what is Vulcan? So Vulcan is a whole new species of timber which has been heat treated and can be used in a variety of different applications. So in this application, you can see here, which is our showroom down near Queenstown in New Zealand. We've used it as structural beams and as internal linings. Some of the key features and benefits of our timber is we do have our own custom designed oil. So we put a lot of investment into understanding maintenance. So a key thing with all of your architects is, well, what's the maintenance? When do I need to wash it down and so forth? So we've actually got maintenance manuals and we've actually got weather testing on our YouTube channel and on our website as well. In terms of us compared to an oiled hardwood, we would be probably half the amount of maintenance. In fact, you can see it in this image. This photo I took of a project on the bay in Melbourne, in Brighton. It's showing at about 18 months old. So it's still looking really, really good at 18 months old. Really key thing about our Vulcan timber as well is it doesn't leach tannins. This is a project I completed a couple of years ago. These pictures were taken about 12 months after completion. So as you can see, there's absolutely no leaching marks as well. So really great for around pools and you know, if you've got expensive stone, that kind of thing. The Vulcan timber is also very, very lightweight, so perfect for garage doors. I've been doing a lot of garage doors here in Sydney, and I know we have been in other states as well. It is literally half the weight of something like a spotted gum or a black bud. So very, very lightweight. We're also very good in set lengths as well. So because we are from a pine plantation rather than from natural hardwood forests, lengths are really, really good, and we can do lengths up to 6 meters. In fact, this job here I'm showing you, I saw last week and took these pictures last week. The client wanted 1,000 pieces of 42 by 42, I think at 3.6 meters long, which is kind of crazy and something you would never, ever do in hardwoods. Timber is incredibly stable. as well. So in terms of fixings required, you would require half the amount of fixings. So in this slide here on this 42 by 42 batten that you're seeing, normally on a hardwood, you'd actually be requiring a fixing every sort of 600 or so. For us, it's about 1.9. So here you can see, and this is what we've been starting to do a lot of, is these very large sections. So this section size is like a 238 by 42, and we were able to clear span floor to floor. And coming up to the end, we do a lot of joinery as well. So this is an office which we did the complete fit out in Queenstown in New Zealand. So, you know, whether it's skirtings, architraves, windows, shelving, that kind of thing, we do a lot of joinery. It's a very, very versatile timber as well. And probably most importantly, fitting into our theme for today is it is highly sustainable. So it is plantation grown in New Zealand. It is FSC certified. So because of FSC certification, there has to be a minimum of 10% of natural flora and fauna within the forest. In fact, these forests are open for anyone to go visit and actually enjoy, go hiking or mountain biking and that kind of thing. We are red list free as well, so it's great for the Living Building Challenge. We've been working on a few Living Building Challenge, so it's completely chemical free. And I'd say we're probably one of the only solid timbers here in Australia which has a EPD or environmental product declaration. So we know for a fact that in our timber cladding, there's about 9.5 kilos of carbon per square meter. So all that data we have had independent experts. So what I'm just going to do before I hand over to Jed is I've just shared a poll. If you wanted to see some small samples, you've got one option. If you wanted to see some further digital info, FSC certificates, that kind of thing, please reach out. So I've just shared that poll where you can get further information on our Vulcan timber. And a key thing, what I actually do here in Sydney, we don't actually have a showroom here in Sydney, because as I tell a lot of my clients, the 30, 40, 50, 60 projects I've completed in Sydney over the last 5 years, I use those as my living showroom, and it's an amazing tool to be able to send a client past projects we have completed that are several years old as well. So I'm just going to switch over to Jed, and Jed is going to tell us a little bit more about himself. First up, and a little bit about his background, a little bit about XFrame, and then he will get into his presentation. Now, a lot of you have just joined in, so I just want to say again, if you struggle to get the test sheet, it is in the handouts as well. I'll leave it over to you, Jed.
Cool. Hi, everyone. Thanks, Steve. Thanks for joining us. Coming to you from Wellington, New Zealand. My name's Jed. I founded a company called XFrame 3 or 4 years ago now. We specialize in interior demountable circular partition framing systems and cladding solutions. We are based in Wellington, New Zealand, but service projects right throughout Australia, New Zealand, into the US and into Europe. This presentation is really focused around how do you make the most of circular demountable solutions in interiors. We know there's a major emphasis on reducing the embodied carbon in these fit outs, and this presentation is helping you all as architects and designers approach some of these problems. Like Steve said, please just drop any questions you've got in the chat as we go through, and I'll do my best to answer them. So I'll kick us off. I hope I'm speaking to a group of converted here. We all know that our industry is a major cause of emissions and impact on the environment. Particular thing that we as XFrame are interested in is the waste that's created. And so we know that the construction industry is not only the largest producer of solid waste of all industries, but it also consumes the most raw materials. And this information really points to a sector that isn't set up for circularity. It's not something that is designed to steward and reuse and recover materials. Instead, it's very much of a linear operation in the sense that it really take, make, and dispose. And we also know that when we build, a large component of the waste that comes out of these buildings is has very little value. So it's either demolished and crushed timbers, which have to be burnt, incinerated, or it's scrap metal products that are reprocessed into lower grade steel. So it's not an industry where we see high value reuse. And our mandate as designers in the 21st century is to ensure that the spaces we design now are fit for the future. And again, with a major focus here today on the interior of spaces. One of the things that we are often not very good at understanding or analyzing is the accumulation of impact. You know, say a superstructure is built, it might last for 50, 75, 100 years. That's the main body of a large building. But actually what's happening is every 5 to 10 years, some of those office floors or plates will be completely demolished and refit to suit modern office standards or a new tenant. And within that process, we're gonna see about a 38 to 40 kilograms per square meter of floor area waste created. So it's a significant amount of waste over time. And that has a direct correlation with the quantity of emissions that are created during that process. And so you can extrapolate this out. You can say, okay, if I look at an average fit out, maybe it's a retail tenancy, 300 square meters, you're going to see, you know, over 11 tons of waste come out of a typical fit out when you do a refit, but also about 28,000 kilograms of CO2 emissions that are resulting from materials not being reused, recycled, but simply being dumped. And if you scale that up, if you look at what happens at a much larger office plate, say in a major centre like Sydney or Melbourne, those emissions just scale and get nastier and nastier. And I've tried to correlate that for you so you can understand the impact and communicate that to clients. But in a 1,500 square metre fit out, we'd expect to see almost 150,000 kilograms of CO2 emissions. It's over 7,000 trees growing for 12 months. There's an immense amount of emissions that are taking place. And for us as a petition supplier, the reason we do what we do is because a large amount of that waste is petitions. It's wall finishes and the structural framing that goes into it. Anything from 50 to 75%, depending on the design of that space, will be petitions that are going to landfill. So that's a sort of a background and context to what we're talking about today and the problems that we as an industry face and the things we need to start actioning. The rest of the presentation is very much solutions focused. So it's how do we go about creating circular low carbon solutions to address the problems that I've talked about. I'm going to come at it from a few angles. There's the circular economy theory, which is just an important piece of context to understand. But then there's some very practical, tangible, design-based responses, whether that's material specification, like Steve was talking about at the start, or geometry, modularity, the way things connect together, fixings and hardware, as well as supply chains. So we'll go through those one by one. As I noted, I think it's really important to zoom out and view circularity as a movement. It's picked up a lot of momentum in the last couple of years. It's a very old idea. It came from the 1960s, the Whole Earth catalogue, some of you may be familiar with, where we really looked at the Earth as a system and said, okay, the systems that are operating within this are closed loops. Everything is contained within the planet. Everything has to exchange energy or exchange materiality with something else. And so circularity is the manifestation, or the economic human civilization manifestation of that. How do we take a material, get as much possible value out of that material through all stages of its life? How do we ensure that that material holds some sense of purity or substance through those use cycles? The way we understand circularity, and I apologize for the slide that's somewhat confronting in front of you, it's two sides. It's called a butterfly model. That's because one side of it deals with materials that are designed to biodegrade, to naturally break down in the environment, and one that deals with technical nutrients, things that are manufactured that are indeed not designed to break down by design. There is a little bit of tension here, and as a modified wood company, I'm going to talk about that. Timber products are really difficult in a circular economy because in some respects they're a biological nutrient. They're designed to break down. But many of the things that we do to timber, i.e. treat it or laminate it, press it, peel it, veneer it, all these things have an impact on end of life. And we have to be really conscious of that. There's a whole lot of adhesive technologies that are coming that are bio-based and use resins from trees and have that sort of technology under them. There's friction welded timber. All of these solutions are coming. But right now, when you're specifying timber, although it's a wonderful low carbon and quickly renewable solution, we have to be aware of how it's fixed, how it's designed, and indeed how those elements can be reused and recovered before we look at end-of-life management. I just learned today, which is fantastic, that Australia has its first particle board recycling scheme in place. And so you are starting to see movement in terms of engineered wood products being recycled. And that's a great thing to see. And it does give you as designers a much better, I guess, breadth of specification. You know that some of these products have recovery schemes at end of life that are not just incineration, but instead high value recovery schemes.
Do you know what that scheme is called?
Not off the top of my head, sorry.
No, that's okay. That's okay.
But we can share that later on.
Yeah,
by one of the major particle board suppliers in Australia, which is great. Yeah. I've got another slide of the circular economy and how it operates in construction, just to try and break this down for you. And it's dealing with finite materials and renewables, and it's trying to track how materials like timber operate in a circular economy. One of the things to understand is the value of emissions offset today is treated as a really high significance versus emissions offset in the future. And what I mean by that is there's a definite argument in circularity for using really durable materials, steel, because it lasts a long time and it can be recycled. But we've obviously got a climate emergency in the sense that we need to offset emissions immediately. And you cannot do that if you're using steel products and specifying more and more steel products. So there's a real urgency around using materials today that have a low carbon performance. And there's some research out there that looks at how long you'd have to use a piece of steel before it was better than a piece of timber. And you're talking about 700 years. So there's such a duration in terms of impact from steel that timber products have a much better immediate impact. And indeed, for 700 years into the future, we could see timber having a better impact in terms of emissions and reuse rather than steel. So there's some complex calculations there obviously go behind that, but that gives you a high level understanding of how it operates. Oh, thanks, Kristen, for the redirect recycling link. It's perfect. It's exactly who they are. So I'm going to go over what XFrame does to address this need for circularity, how we operate, how we make decisions. These are philosophies, so they're definitely out for debate. There's definitely nuance to them, and I'm really opening a conversation about it, and I hope everyone has their own sort of opinion and take on some of these matters. So the first one I'm going to talk about is designing in layers of change. It's an idea that came from Stuart Brand, who's an architect and author from the 1990s. He came up with this idea of every layer of a building is a separate timeline. You know, the spaces, the stuff that's within the spaces, what's on the walls, the surfaces, they all change over different periods of time. And what we need to do is design for that change. So in a commercial office setting, right, we would expect in 5 to 10 years, there may be a tenancy change. So we would expect all the stuff in that office to be gutted. So that's your furniture, maybe your soft furnishings. They need to be readily recyclable, easy to be removed, items that can be reused, recovered, re-engineered and refurbished. And that's where the furniture industry, I think, are doing great things, particularly in Australia. There's a few companies who have take-back schemes, who have stewardship schemes to look after those goods because they know it's a short life cycle. The next element that we look at is the space plan. So that's your 5 to 10 year cycle, 5 to 15 year cycle. That varies a lot. Leases can have impacts on that. Building regulations, shifting economic conditions can also impact that. And that's the architectural spec. That's your internal partitions, maybe some of your ceiling systems, any services that are linked between those spaces. And that's where we as interior designers, as interior architects, as architects can have a massive impact. So this is how XFrame addresses this problem. One of our sort of mandates is to create spaces that are as easily changeable as possible within the context of buildings. So obviously, building space is big, it's heavy, it's complex, it's often difficult to get to the site. You know, we could be building space on the 30th floor of a building in the middle of Sydney. We need to create spaces that can change. And so one of the key mechanisms that we do is we disconnect ourselves from the overhead ceiling system. That gives you flexibility. It means you don't have to worry about interfacing or making good that ceiling system when you pull the unit out. It also gives you flexibility in terms of where items go. And there's different mechanisms for disconnecting the service allocation. So if you need to have spaces that aren't connected to the main service supply of the building, whether that's HVAC, you can do that with with demountable systems. So room in room is the philosophy we use there, very common in North America, and we're starting to see a lot more of it in the Australian market. Another philosophy under this layers of change approach is layer separation. So because the XFrame is a self-braced diagrid, it's a rigid structural frame, what that means is we can accurately predict where the fixing points on that frame are going to be, and we don't have to support the frame with a lining material to brace it. So any seismic or wind loads, the frame is inherently dealing with that. Because we can do that, we can clip this lining element on and it becomes a demountable solution and demountable system. If a tenancy changes, they need to rebrand, they might want a different colored lining or a different finish in that space for whatever reason, they can clip these linings off and swap them out. They could refurbish them, they could stain them, they could recycle them. All of that becomes an option. And critically, what's happening here is those lining materials aren't damaged in that interaction, and there isn't any contaminants that are going through. So there's no adhesives or damage to the faces or rear of those panels as they're mounted. And I'll go a little bit later on into how that mounting solution actually works. What we do is we cut a clip solution into the back of it. It's called a single-sided clip, which means that the board itself doesn't have any material modification, i.e. we're using the material board qualities, the timber, we're creating a negative rebate, like a French cleat solution out of the timber, and then we're hanging that onto our clip system to achieve the layer separation. Like I mentioned earlier, one of the critical things that needs to happen when you're designing room-in-room spaces and spaces that can change is you need to untangle all of the services and systems that go with it. In Australia, there's a wonderful company called My Modular. They have a demountable plug-and-play electrical system, which allows you to essentially have a 3-pin plug that you might plug your vacuum cleaner in with, that plugs a whole space in, which if you think about the advantages of that in terms of simplicity of end-of-life demounting and change, you don't have to call an electrician. Your builder can simply unplug it and unthread the cables and then use that system in another fit out or take that system back and modify it. That includes everything. Your downlights, motion sensors, GPOs, data can all be run through that system. So you can create an entire space that is completely plug and play by design. And we pre-cut our framing members to allow the My Modular system to work with it, to run through the frame members. Creates a very simple approach. You can also think economically from a programming point of view. You no longer have to wait for your electrician to turn up to the job site. You can just ask your builders to run the cables. They don't always like that job, but hey, it does save them a little bit of pain because they can go at their own pace. They're not waiting for other services to come through. Another key approach and one of our 4 main pillars here is standardizing for future reuse. It's probably one of the most complex areas of circularity, i.e. what we're trying to do is come up with a standard asset that may have future value because of its size, shape, and properties. And that's always completely dependent on economic conditions, right? What is the market wanting? Do they want larger rooms? Do they want smaller rooms? Do they want panels that fit in a certain size truck or elevator? And we've arrived as an industry at this standard of 1.2 by 2.4 meter sheet materials. And so there's kind of a historical norm that we're having to follow. It might not necessarily be the most efficient spatial planning unit, but it is a material unit. And so what we've done is adopted a 600 millimeter planning grid. That means everything is on that grid from a planning point of view, and we systemize based on that. So our sub-assemblies, our wall panels, our roof panels, our window panels, our door panels are all based on that base 600 millimeter module. Doesn't mean you can't have custom. So you can have any circular or non-linear component or custom length component that you want. But what you're doing is introducing differentiation, or you're basically introducing a variable into your planning which has less value at end of life, is more difficult to reuse. So we know if the building is run perfectly off a 600 millimeter grid, we'll get very high standardization, very high material efficiency utilization, very low waste, and very high standardization for reuse. So here you can see one of our installers mounting a window unit. So that window is mounted within a 600 millimeter panel. And it's this whole idea of creating an interconnected system of parts. The more things that you bring within that system, the more standardization that you get. Like I mentioned, you're not actually locking yourself out of creating custom componentry. This is a customer in particular who wanted a nice curved corner post So we supplied that as part of the kit of parts. It's not an off-the-shelf solution that we would produce, but it's something we produce for the customer so they achieve their design outcome while still working within the bounds of standardization. The other thing you'll notice there is that we've essentially got a 2.4 meter high panel, which is the white section, and then a little pink section at the top, which is an extra 300 millimeters. Very, very common in sort of that ground floor retail space is to have a ceiling height that might be at 3 or 3.6 meters. So what this solution allows you to do is to have a 2.7 meter high wall panel that has a parapet. So the space has a nice proportion in that higher ceiling space. And then when you go into the room, you have a false ceiling at 2.4. So you get an acoustically controlled space within a larger volume that is fully disconnected and has standard parts. And so in this case, these modular sub-assemblies are actually working at 2 scales. They're working at the panelized system, the 1200 module, but what they're also doing is internally, they can be reconfigured to be different heights. And that gives you the advantage that if you did need to go into a new tenancy that say had a 2500 high ceiling height, you could swap those plates at the top to be suitable for that 2500 high height. And then you're being able to reuse up to 90% of that panel. So that's reuse and circularity working across different scales. And it's really important when you consider circularity, what is the downstream implication of the decision you make up front. So that's the model here. We've got these standardized parts that go modular panels into adaptable spaces, and they kind of work within each other. Obviously, the most efficient reuse parameter is not to have to modify the panel. That's the most economical because you're not having to exert additional labor to do that, but it's not always possible. We quite often deal with retail tenancies that might have a 2550 or a 2400, and in that case, we'll create a panel or modify a panel to achieve that. This is what we mean by tartan grid planning. So when we follow a grid offset, what you're seeing here is a 600 millimeter grid inside the space. And then every time a wall intersects itself, it offsets itself by the thickness of the wall. The advantage of this planning approach is you end up with great standardization across all of the layers. So what I mean by that is you end up with panels that are all the same, linings that are all the same, and any of the offsets required due to the thickness of lining materials or the finishes on the wall are dealt with in the corner intersection. Gives you great standardization, gives you a very simple planning logic, and it means you can create intersects and you can create hidden conditions and sort of hide the modularity of the system within itself. There are different planning methodologies that are always appropriate. Some buildings, for example, might be long and skinny rectangular objects in which you just need a partitioning dividing wall between existing structures. That's where we would use a system called isolated planning, basically where you're just running wall lengths between existing infrastructure. You can also use centerline grid planning. That's more for really complicated nuanced plans. You might have a whole lot of small intersecting spaces that are non-linear. That's when you need to deal with more custom elements to achieve that planning configuration. And so one of the interesting approaches that we can take with circularity from a spatial point of view is we can take an architect's plans, we can run a script over that plan and look at the degree of standardization that's occurring within the footprint of the level plan. What that means is we can improve the amount of standardized items that are going into it for the purposes of circularity, for the purposes of efficiency, simplicity in construction, demountability and reconfigurability. So there's a whole lot of benefits that come from this. And we can go through a series of iterations with you guys as architects and designers to find a more standardized solution that doesn't compromise your design outcome. And that's the real complex part of circularity is balancing the need for unique design outputs, to suit a customer's brief or to suit a particular design intent, while trying to achieve as much standardization and interoperability as possible. And I think it's important to recognize is that different customers expect and need different things. So large corporates, for example, they might have portfolios of hundreds and hundreds of properties where they can create their own network of parts within themselves, their own little circular loop within their own property portfolio. But you might be dealing with a one-off client who just has a need for a particular outcome. And that's where you have to somehow balance, how can this customer use something that could be reconfigured later? What would be the value of that to another person? And how do we sort of deal with something that's bespoke or something that can be reused? And that 3D spatial analysis can happen both in plan and 3D, and it's important that it does happen in 3D because you do often end up with undulations or changes in heights, and you need to optimize for that. This is kind of getting really into the weeds. So at a data level, what you should be doing in circularity is producing a materials passport. That's a list essentially of everything that's going into a project, so that when we come to refit or recover, we've got a list that we can audit, pull materials out and reuse them. And that's the process we run for producing parts and stocking parts and reusing parts, is where we're actually tracking what goes into a panel from an element level, screws, bolts, washers, X-frame parts, checking what's in stock, checking what needs to be produced, and creating a bill of materials based off what's available in the market. And as I mentioned, it's not about creating spaces that are all identical and locking ourselves in from a design point of view. It's an open book from a design approach. What it is all about is ensuring that there is modularity and demountability within a network of parts. And so what you see here is our most recently completed project. This is a Living Building Challenge project here in Wellington with Meridian Energy and Unispace in a large historic building where they wanted to create room-in-room solutions to give them a really high-performance acoustic space that could be fully demounted, that didn't have to interact with the old heritage building. And so this client wanted the sweeping curve in the corner of each room. That in and of itself is a custom bespoke solution, but then in amongst that is all of our standard elements. And that's why we approach it from that way. We have smaller sub elements that form panels that then can be used interchangeably with other solutions. And here we have a few different window and door configurations that are slight modifications on a typical approach. And that's what you might expect. By the time it's all wrapped up and beautifully enclosed, you wouldn't really know that it is X-frame at all. It is just a nice space to occupy. The third pillar that we approach circularity from is materiality, and I'm sure everyone on this call is passionate about this. It's something that as designers and architects, we really need to commit to specifying materials that really work in circularity. Just sort of reminding ourselves that there is two sides to material handling and circularity. There's the biosphere and the technical nutrients that have to be dealt with separately. And timber is trying to ride this awkward middle where sometimes it slips into a technical cycle and sometimes it's purely biodegradable. And that, as I'm sure many people on the call know, has implications for carbon accounting, because how do you account for a material that has a sequestered carbon component that may not be reused, that may be released? But even more complicated than that, it might come from a forest that had carbon emissions or credits sold from it. So how do we begin to account for that emission cycle? What I'm going to present to you now is a series of numbers. These are biogenic and fossil emissions nets. So what they do is they're adding those two numbers together. Now, I know there's different ways of calculating this according to the standards. The reason I'm showing you this is for the purposes of multiple cycles of reuse and the implications of reusing timber. There is, again, if you're doing this technically following the book for carbon accounting purposes, you would be reporting both fossil emissions and biogenic emissions separately. What I've got on the screen here is three standard approaches to walling. So we've got steel studs, steel partitioning. You'll see that in a lot of office buildings and retail buildings in Australia. Timber studs, more of a legacy system in those larger fit outs, but still sometimes used, and X-frame. What you're seeing is obviously the weight, which is the amount of material going in many respects, and then the related carbon emissions or net carbon that is associated with that solution. So you're seeing different variants of emissions. X-frame slightly lower in its sequestered or negative carbon value in the frame carbon up front because we're using plywood, so it has more obviously tangible manufacturing costs. There's adhesive in it versus not having the adhesive in a timber stud. We're also using less timber, which means that you're sequestering less. And this is why obviously everyone knows that it's important that we don't load our buildings full of timber, because you're not actually helping the environment. You're just sort of shifting emissions around and causing problems. I do have a little note at the bottom. Little note at the bottom to say income.
I'm joking. Less is more.
Less is more, exactly. So one thing to consider is that the emissions associated with glass is so much more than a timber wall product. So you're looking at about 50 kilograms of carbon for an acoustically rated piece of glass. per square meter of wall area. That's a lot of carbon. And it will be very difficult to reconcile that with a solid wall system. And so again, like Steve just said, less is more, less glass is more. So you can't just fill an office with glass anymore. You simply won't meet the carbon budgets or carbon requirements that are expected. Just expanding that table out, so you can look at the emissions associated with the lining product. We'll all know that plasterboard is a poor performing emissions product, i.e. it has quite a high emissions profile. So any timber-based substrate or timber-based board product is always going to perform better from a carbon point of view in terms of a wall lining. And now that we've got a particle board recycling system in Australia, we have an ability to recover a lot of that waste and actually reduce those end-of-life emissions for the particle board, which is a really exciting proposition. What this boils down to, when you look at it from a multi-cycle reuse point of view, circularity, is that systems designed for recovery will have lower carbon emissions over multiple use cycles than a system simply designed for one use cycle. So for example, if you follow that steel stud row across, you'll see you've got about 10.1 kilograms of emissions per square meter of wall area. When you go and reuse that, assuming you can recover the steel and recycle the steel, and you do go through that process and you recycle the plasterboard, in that second life, you're still going to emit another 5 kilograms of carbon because you've had to reprocess materials. You haven't been able to reuse them. There's a much higher energy component to remanufacturing those materials. Timber, what we'd expect with a timber frame system is you're only going to get somewhere between 5 and 10% of tangible recovery. So that's if you gently pull the plasterboard off the wall, de-nail or de-screw the studs, and then try and reuse it, which we know, given how expensive labor is and how expensive resourcing is, that simply isn't done. Those materials are typically landfilled. So when you go to do the second life, what you're producing is the same amount of emissions that you put into the first life. There's probably going to be another 9 kilograms of emissions per square meter because you didn't reuse components. When you get to a circular solution, and again, being an advocate for circularity, XFrame is just one solution here. There's many circular walling systems that exist in the market. Because you're achieving such high levels of material recovery, in excess of 80% typically on most projects, what you're doing is you don't have that material consumption cost for carbon in that second life. And so you're achieving much better carbon offset emissions. And that is how, when we look at these carbon budgets for fit outs that are coming through from government and from large consultancies, the only way that we are going to achieve those targets over the long term is if we have circular solutions which completely negate the emissions when you go to reuse and reconfigure. That is the only tangible way to do that. And we have many long-term benefits for doing that. We're cutting down less forests. We're having less long-term impact on waterways and erosion and production and emissions into the atmosphere. So there's so many offshoots of the benefits of circularity, and I hope that this worked example helps you understand that from both a carbon point of view, but also all of those offshoots. What we do is just to help everyone understand this and get this conversation front of mind when we're engaged in a project, is we'll produce a carbon report. We'll show people the emissions associated with the specification. We'll show people where those emissions are offset. And unlike what I've just done in the presentation, we will report those raw fossil and biogenic emissions separately, so you can fully understand where the biogenic emissions are, if they can even be considered as offsets, and if they should be, versus just the raw fossil emissions. All right, hopefully that wasn't too technical and boring, you guys. We've still got you. The last section here is fixings. So like I mentioned, the need for fixings that separate the functional layers of buildings is absolutely critical. It's the way that circularity can operate in an elegant and efficient manner. And one of the things that it does enable is economical deconstruction. So if you have, for example, really sophisticated fixing systems, but it takes hours to pull things apart, then you aren't incentivizing people to reuse or deconstruct. People are going to get frustrated and they're going to throw that thing out. And so creating systems that are easy to separate, like clip-on polyester linings or clip-on rigid linings, allow that deconstruction to happen much more quickly and much more easily. What you see on screen is our own clip-in system. Like I talked about, it really is a single-sided system, and that's designed for economics and architecture, scale, and the ability to ship hundreds and hundreds of linings flat-packed without clips running into each other or breaking or becoming damaged. It's only one solution. French cleats, split battens, fantastic solutions that are used extensively in the industry. There's Ortex has come out with a polyester lining clip system. Desorb in New Zealand have their own clip system. Fast Mount, another great New Zealand company that has a fantastic clip-on demountable lining solution. And all of these products are trying to solve this problem of dependent layers, demountable linings. We recently completed a very large fit-out project in Adelaide, and one of the things that became evident is when you have a large fit-out project that is in a very short timeline, your sparkies may forget to run a cable, or in fact, the specification for that cable may not be ready in time until after the wall's been lined. And so when you've got a demountable wall lining, everyone breathes a sigh of relief because they can clip the lining off, they can run the cable and clip the lining back on, and there's no damage. In a traditional job, that would have been a cut through the plasterboard solution and a mess, and everyone would have been pretty unhappy. And just showing you how this works. So the clipping and demountable lining solutions can come in all sorts of forms. Here we're using a polycarbonate lining and a birch shingle. We did some work with Watso recently, which is a large co-working company in Australia. This is in their Liverpool space in Sydney. It was an old gutted office space, came in there with a very specific Watso look. If you've ever been to a Watso co-working space, this is what they look like. We lined those spaces with Saveboard product, which is Australian manufactured now. So again, a great circular story and a demountable lining solution to suit. This is kind of going to the other end. This is the more corporate premium end that we service, and you can see a polyester, a PET product with a clip-on and a vertical groove to kind of hide some of the modulation that's occurring within that. The fixing sort of considerations are throughout the system. So what we're trying to do is always decrease the quantity of fixings. So it's a simple deconstruction process, kind of like what Steve mentioned at the start. If you're reducing fixings, you're going to make the builder happier. Things are much easier to pull apart. There's less maintenance issues. And so we apply that same logic into the system. So we just have a very simple bolt fixing between panels and between junctions, and same thing into the floor. And that's flowed through the different cassette options or different panelization options, depending on the project's requirements and just what is needed in a specific job. All right, that's our 4 pillars and hierarchies of circularity. That's how we try and operate within XFrame. Again, we don't pretend that that's the perfect Bible for creating circular demountable spaces. It is merely an approach. It's an approach that's based on quite a lot of research and consideration. And as things evolve in terms of materiality, there's also an impact of how spaces can become more circular. I like to put this photograph up, or these 2 images up, because you can see just a stark difference between what is the status quo and what we need to be aiming for. And like I said, regardless of whether it's XFrame or another circular system, there is an urgent need to implement demountable solutions inside of fit-outs. There's thousands and thousands of square meters of fit-out being built every day that are not designed for change, and we need to fix that as an industry. That's what we've covered today. I hope that's got everyone excited and motivated about implementing circular solutions. And I think it's really up to us as professionals in this space to encourage our clients to act and to specify the right materials and the right solutions. Yeah, and I'm keen to take some questions and have a bit of a chat about it.
That is really, really, really cool. It's like that old Meccano system that I had as a kid, but like exponentially cooler, because it's not a little toy. It's actually something that meets a need in the market in every way. It is circular. It's just incredible. There have been a couple of questions coming in. I'm hoping people have got more questions. Jean asked, well, I'll go to Mark's question first. He wanted to, can you repeat the acoustic glazing carbon emissions amount?
Yeah, so depending on the specification and the person that produced the glass, that can be anywhere from 50 kilograms and upwards. I think one thing to be really careful with glass is that the thickness has a massive impact on that rating. So for example, if you've got a 6 to 8 mil rated acoustic glazing, that might be in the 50 kilogram range. But if you've gone up to a 13 or a 14 millimeter laminated acoustic glazing, you're going to push those emissions up. It can be 80, 90 kilograms per square meter easily. And that's before you start to include things like the aluminium track system and the bracing. So something and I always recommend refer to EPDs for this information. Don't take my word for it. Go and look at the manufacturer environmental product declarations. That's where you get this information from.
And then also a really good question is, do your systems meet NCC group ratings, fire, smoke, all that stuff?
Yeah, great question, and it's a really important thing. So we use, depending on the architect specification, we will put whatever they want on the wall. And so what we expect is when we do that, there is a compliance mechanism for that material. So if it's like the product behind me, it will have a fire rating or a spread of flame rating that we can apply, whether that's a group 1 or group 2 rating. The same thing with the timber finishes. So what you see in this image is one of the ANZ retail stores. It is a Tasmanian oak veneer on a particle board. It is clear coated with a Miratone system. According to the fire guidance and technical specification that we have for these stores, they don't need to carry a fire retardant chemical because the spaces are sprinklered. And then that's dealt with by the architects specifying the project or any compliance requirements are. We obviously have material health and safety data sheets and the whole repertoire of information to support that. And indeed, when there is an egress requirement, which might require a group 2 rating on the lining, we'll use a group 2 rated board with a group 2 rated finish to achieve that. And indeed, sometimes there's even hardware requirements for those products to stop them falling off the wall in the event of a fire. Yeah, critical topic and something that is challenging in respect to circularity, because you're having to often put a whole lot of chemicals into a product to get it to be fire rated. And actually that's where plasterboard, bless it, is beautiful, because it's somewhat fire resistant in its own right. So there is a tension there, and there is a lack of, I guess, really effective fire rated boards for circularity purposes. Sprinklers help a lot, and solutions that are just simply designed cleverly to meet code requirements.
And Jean just asked a really good question. Guessing that on a meter square base, your system costs more from a material perspective than a standard commercial partitioning system, but then assume cost savings are in labor/speed of construction. Is there data that can be provided to cost planners? Because it's a struggle to cost modular in apples and apples for standard construction. Yeah,
Jean, I'll try and send you an email after this, but yeah, it's a really challenging area because exactly like you've alluded to, there is labor savings, but you've got to consider the labor savings in terms of overall project time savings. And there may be, for example, an overhead cost with operating that site every day that can be diminished if XFrame's used because of the compressed timeline. You might be able to get sub-trades in faster, so there's less delays. In retail, for example, where you can actually count the dollars lost for that store being closed every day, then there's a whole nother consideration. We also ask some cost planners to consider end-of-life value. So for example, if the client can see the space being remodeled in the next 4 years, for example, they can actually include that in their cost calculations because they can account for the recovery value of the product. I've got an architecture background. I won't pretend to be a QS, but I can definitely help you with some numbers that we have in-house to support those ideas.
Yeah. And then also, I think it was a question on the sheet about what are the 6 temporal layers of construction. You missed that one on the...
Oh, yeah, I'm going to have to go right back. So that's where we're talking about Stuart Brand's theory of layers. So we've got spaces, structures, staff, services, site. Just going to keep diving back. That's it here. So you've got here the primary layers to consider: site, skin, structure, services, space, and stuff. Great little book. It's called How Buildings Change. Really interesting. And How Buildings Learn, I think, is the actual title of that book.
Excellent. And then also external wall construction. This is also from Jean. External wall construction needs to be non-combustible. Obviously, depends on the class/stories. So you only have a timber frame system. Would you typically suggest a standard non-combustible wall component that achieves the external wall performance requirements and your system on the inside to enable the continuity?
Yeah, that's exactly right. We have typically sort of turned away from residential external load-bearing wall work because of some of those complexities. And you're dead right. It's a lot to do with implementing a sufficient solution to meet those fire-rated requirements. And we don't have any testing in-house or verifiable methods, so you'd be relying on another system providing that rating at this stage.
This is an interesting question. Good one, Eva. Do conversations about carbon emissions account for habitat loss as the industry uses more timber-based products, particularly hardwood?
Yep. Yeah, that's an exceptional point. And Australians' fascination with Tasmanian oak is also a problem there, right? We see massive concentration of a particular type of species, and we see habitat destruction and biogenic issues, and the new way of producing EPDs, where we have a land use and land change calculation, is now embedded in that information. So again, I'd say refer back to these EPDs. But again, another reason for implementing circularity. If you've got a system that you don't have to throw out, means you don't have to buy new timber, which means you don't have to cut the forest down as quickly. And that's a really nice long-term gesture.
Correct. And I mean, look, there are things like FSC, so our FSC plantation timber from New Zealand, they have to allow for a minimum of 10% of natural flora and fauna. So they do have to actually take into account. Whereas when it comes to the Australian natural hardwood forests, while a lot of it is PEFC certified, or I think it's responsible wood, as it's called here in Australia, it is a lot looser. And yeah, what actually happens to those forests after it's cut down? Look, from our perspective as a company, in an ideal world, all the Australian forests would be FSC certified. But yeah, in short, really, I don't believe that the carbon emissions do get taken into account, really. For habitat loss. Eva, I do love you. Elle was just asking, what type of grid planning is suited to interior demountable system?
That's one of my questions. That's the tartan grid. So hopefully that's covered.
Oh yes, you just answered that. Sorry. And Eva just said, is an XFrame at Abodo collab coming for certified internal linings? No collabs on the horizon, but we have done or are doing projects together in New Zealand, not necessarily here in Australia. But yes, there is the possibility of the two of us working together on something. Absolutely. So if you have something, I'll drop you a line.
Annalise, just picking up on that, I think it's 38 kilograms. I'm just jumping back to the slide so I don't get it wrong for you. Yeah, 38 kilograms per meter squared.
Alex has just got a really good question. Do you have product name embedded into the product? One of the barriers to reuse we've encountered is organizational memory loss. Yeah, it's a great point. We don't etch our name into every piece. We've considered it, but it becomes so involved. You know, if you're doing 50 pieces a panel, then you've got so many million barcodes going out. What we do is tag each panel, and we also submit to the organization an audit, basically, of what was implemented or sent on that project. But it's a great point. There are some really good material passport softwares that have been released in the last few years that are aimed at facilities managers and businesses to track their assets and their building assets. And I think as we see more modularity, more circularity, and product-based solutions, we're going to see more uptake of those material passports. It just makes sense. Yes, yeah, absolutely. Yeah. We're kind of coming to the full hour. Does anyone else have any further questions or anything else they want to say? I can see one there from Hillary. Something I am going to do very quickly is, Jed, you did share with me a document, strategies for applying the circular economy to light timber framing.
Yeah.
So I've just shared in download. So it's quite a comprehensive guide. Do you want to just tell people what the download is?
Yeah, that's my PhD thesis. So there's a 400-page document there for you to read if you'd like. It goes through the very origins of these ideas from a theoretical standpoint, and then 4 major pilot test projects that we did, and it evaluates everything you can think of down to the shape of the head of the screw for durability and the type of nut that you're supposed to use to be more demountable. And
wow,
some lovely bedtime reading for everyone.
Well, we know architects do love detail and learning the bits and pieces. I mean, I'm talking to you and you're an architect, you know, all the little technical bits and how it all fits together. So I've also just shared a poll just to give some feedback to Ged as well. If you just want to note your answer on what you've learned and what you have or haven't learned. Otherwise, yeah, we'll wrap up now. And thank you everyone so much for coming along. And yep, we will be back in the coming weeks with another presentation on a similar theme. Ged, thank you so much. I really, really appreciate it.
Cool. Thank you, everyone. Great to see you all.
Soon. Cheers.
See you later.